Welcome to the another video. Today we are going to see about plasma arc machining. Let us see what is plasma arc machining. Generally, the plasma arc machining is done by the free electrons and ionized gas. Generally, when a gas is heated to a high temperature, it releases the free electrons and ionized gas. With this help of ionized gas and with the help of this ionized gas, we are going to melt the or remove the material. Initially, we will see how this process goes on. When a solid is heated, it gives gas or liquid. When a liquid is heated, it gives gas. When a gas is heated to a high temperature, a free electrons and ionized gas is released. With this, we are going to melt the material. This process is called plasma machining process. Plasma gas. When a gas is heated to a sufficient high temperature of the order of 11,000 degree to 28,000 degrees Celsius, it becomes partially ionized. It's known as plasma. Plasma is a mixture of free electrons plus partially ionized gas and the neutral atoms. These three put together is known as plasma. Let us see how the working takes place. In a plasma arc machining process, material is removed by directing a high velocity jet of high temperature from the range of 11,000 degrees Celsius to 28,000 degrees ionized gas on the workpiece. This high temperature plasma jet melts the material of the workpiece. This is how the plasma machining takes place or works. With the help of the high temperature, the ionized gas is made to fall on the workpiece. With this, the workpiece is melted and the material is removed. This is the arrangement of the plasma arc machining. It consists of a chamber. In this chamber, the top portion is insulated and it has a tungsten or electrode, and the chamber is being filled with nitrogen or hydrogen. It has a torch, and the bottom side or the lower side is which has a water cooled copper nozzle, and the whole setup is being supplied with a DC power supply, and the negative of the DC power supply is given to the tungsten or the electrode, and the positive side of the power supply is being given to the water cooled copper nozzle, and the workpiece is placed down to the chamber. When the electric supply or when the power is given to the chamber, the plasma flames are formed, and with this heat energy or ionized gas which is released from this chamber tends or melts the workpiece. This is how this process takes place. Generally, plasma arc machining is a roughing operation to an accuracy of around 1.4 mm with corresponding surface finish. Generally, this plasma arc process is being used in all materials which conducts electricity. We use a plasma jet as a tool. The velocity of plasma jet is 500 meter per second, and power range is 2 to 220 kilowatt. Current is as high as 600 amps. Voltage is 40 to 250 watts. Cutting speed is 0.1 to 7 meter per minute, and material removal rate is 145 centimeter cube per minute. This is what the accuracy of the plasma arc machining process. Let's see the types of plasma arc torches. Generally, we have transfer arc type or non-transfer arc type, or direct plasma torch or indirect arc plasma torch. We will see what is a direct arc plasma torch. In this process, the cathode or the DC power supply is being connected. The negative side is connected to the cathode or the electrode, and the positive side is connected to the workpiece. When the power supply is being given, the pre-arc or pilot arc is created, and that this pilot arc tends to create tends to make the workpiece to melt or to make the plasma fumes, so that the workpiece is melted. This is how pre-arc is created between the electrode and the nozzle. When this pre-arc touches pre-arc touches the workpiece, the current flows from the workpiece to the electrode. This makes an main arc between electrode and the workpiece. So now the pre-arc is switched off. This is how this direct plasma torch method works. The arc is formed between the electrode and the workpiece. In other words, arc is transferred from electrode to the workpiece. In indirect method, the DC power supply is connected to the cathode and the positive side is connected to the nozzle. In direct method, the positive side is connected to the workpiece, and the remaining the procedure is same in this indirect arc plasma method. Here the electrode and the water cooled nozzle is connected. The electrode and the nozzle is connected. The plasma comes out of the nozzle as a flame. The main advantage of this process is it can be used to cut any metal. Cutting rate is high as compared to ordinary flame cutting process. It can cut plain carbon steel 4 times faster. It is used for rough turning of very high difficult materials. Due to high cutting, the deformation of sheet metal is reduced while the width of the cut is minimum and the surface quality is high. The disadvantage is it produces taper surface. Protection of noise is necessary. Equipment cost is high. The protection of eye is necessary for the operator as it produces the flames, so it is very necessary to protect the operator. Oxidation and scale formation takes place, so it requires shielding. Work surface may undergo metallurgical changes due to the flames. The application of this process is it is used for cutting alloy steel, stainless steel, cast iron, copper, nickel, titanium, aluminum and alloy of copper and nickel, etc. It is used for profile cutting. It is successfully used for turning and milling for hard to machine elements. It can be used for stack cutting, shape cutting, piercing and underwater cutting. And also the uniform thin film spraying of refractory materials on different metals, plastics, ceramics is also done by this plasma arc machining process. I hope this video helps and it is very useful for the students.